Okay, let's take a look at this question. It's a transformation of graph question. You're supposed to draw on separate diagrams these transform graphs, and you're supposed to label all the coordinates of the turning points, any points of intersection of the axis, and the equation of the asymptotes where possible. So the first one is a reciprocal graph, and you have to recall that this means that every coordinate xy on the original graph is now going to become x comma 1 over y. So all these y values are going to change. Notice there's no sign change, so whatever is positive remains positive, whatever negative will remain negative. Now there'll be special cases where when the y is 0, we then get an undefined point, and that will also refer to the asymptote. Okay, so let's go through the main points that are given and the features, and see whether we can transform them to the new key features of the new graph, which we will then label it in first, and then we will see how to sketch and join up all these key features. So first and foremost, we have a vertical asymptote, x equals to -2. So this is where the y is currently undefined, and so when you have 1 divided by undefined, here we actually change it to a intercept. So over here it becomes -20 is our new x-intercept. For our horizontal asymptote, notice all our y values will be 1 over y. So here we have 1 over 10, still a horizontal asymptote. For the points, we just try to change it into the y coordinate to be the reciprocal. So here will be 1/4. 0, 6 is going to become 0, 1 over 6. And finally, this one where we have 0, right? The intercept, it will now become an asymptote, vertical asymptote. So notice intercept becomes asymptote, asymptote becomes intercept. Okay, so here we now have our new vertical asymptote, x equals to -3. Okay, so with all these features in mind, we can start to put down our key features of the new graph. I will highly encourage you to draw the asymptotes first. Okay, notice the asymptote has changed. It's no longer at -2, so I made a small error. It should be at -3, where initially it was an intercept. So over here, we're going to have roughly, okay, please use a ruler for this, x equals to -3, so that will be our vertical asymptote. Okay, then we have our horizontal asymptote at 1 over 10. So notice initially it was a +10, now it becomes quite small, so I'll just draw it a bit closer to the axis. Okay, so this y equals to 1 over 10. And with the asymptotes placed down, now you have a frame of reference where the other things come into play. Okay, so let's fill in the rest. -2 is now an intercept. So here we have -2, 0. Now our OY intercept is going to be at 0,16. Now keep in mind that we have another point here which was the minimum. For the reciprocal graph, a minimum will become a maximum. So here just take note that this will become a max point because initially it was a min. So here we have a turning point at -1, 1/4. So maybe I'll just place down this point over here. This is -1, 1/4. Now the y-intercept is now a bit lower at 1,6. So just draw it a little bit lower here. This is 0, 1,6. Okay, so this is our point A prime, this is our point B prime, and C has now become a vertical asymptote. Okay, so this is roughly the key features for the transform graph 1, 2, 3, 4, 5. Okay, from 1, 2, 3, 4, 5. And now the last thing is to join up the graph. Okay, let's keep in mind some features, or rather the trends. So for a reciprocal graph, if the initial graph is decreasing, we expect our reciprocal graph to be increasing. Okay, so this is the behavior up to this -3, which is over here. Thereafter, here is still decreasing, so we expect here to be increasing as well till the asymptote. After the asymptote, it now becomes a decreasing all the way to the turning point. Okay, so here is decreasing. I expect it to be increasing all the way up to the turning point. And then here we are increasing after that. So in our reciprocal graph, it should be decreasing. And after the intercept, it is increasing afterwards. And here we expect it to be decreasing. Okay, so with all those in mind, let us draw the graph. Now, our initial starting point will be above the asymptote versus under, right? This will become above. And we know that it's going to rise all the way to the asymptote. So that means that we are going to end off over here beside the asymptote. So it's always useful to mark a little point beside the asymptotes, knowing that you will join up these 2 points. So I will now join it up. Okay, let me use purple. Join it up. Okay, so make sure that near the asymptote it is tending very close towards it. Now afterwards, we are still rising. Okay, we are still rising until we reach the intercept. So here we are rising from the bottom, touching here. Okay, how do we know it's at the bottom? Remember, what's negative will stay negative. So between -3 to -2, we are in the negative region. So here is negative region. Okay. Now thereafter, it's going to continue rising up to the turning point. So let's cut through the intercept, rise to the turning point. Thereafter, it will start falling towards the intercept, and then thereafter continue to fall towards the asymptote. Okay, so we're going to have a turning point, fall to the asymptote. Alright, so notice that my graph thereafter is going to be flat. So actually you can just cut off your graph over here so that you don't have to extend it so far. If you already drew so far, then please make sure you extend your graph to the end. Okay, so this is our transform graph. Okay, so let's just compare to the original. Okay, what's positive will remain positive. So here refers to here, positive. What's negative is over here, negative. What is positive remains positive. What is positive remains positive. Okay, here we are falling, here is rising. Here we are falling, here we are rising. Here we are falling, we are still rising. Only after the turning point we are rising, so here we are falling. And after the intercept, we are still rising, so here we are falling towards the asymptote. Okay, so if you are not sure where, with respect to the asymptote, your graph should be, I mean, you can visualize some numbers. So for example, here, this is y equals to 5, somewhere in the bottom of the asymptote. The new point will be above the asymptote. Why? Because here will be y equals to 1/5. 1/5 is greater than the asymptote of 1/10. Okay, so reciprocal graph has this idea of opposites changes. So down, what goes down now becomes up. What was a min becomes a max. What was a asymptote now becomes an intercept, and vice versa. Okay, so this is our reciprocal graph. Now let's move on to our derivative graph. So same graph to refer to. Again, we try to find the key features that these will transform into, and then we shall mark it down on the graph and proceed. So for a vertical asymptote in our original graph, it will still remain as a vertical asymptote because the gradient at this vertical asymptote is also undefined. Okay, so in fact, let's draw in our vertical asymptote straight away because we know that it will be present, x equals to -2. Now for our horizontal asymptote, y equals to 10, ask yourself, what is the gradient tending towards? Right, as it goes towards the extremes, which is kind of flat, we see that the gradient is also tending towards 0. So dy dx tends to 0. Alright, so we can just also, let me just write it here, that all the coordinates xy has now become x comma dy dx. Okay, the gradient is now your y coordinate. So we always take reference to what the gradient is at that location. So for the horizontal asymptotes, it will become just the horizontal asymptote y equals 0, which means that these are virtually gradient 0, right, at the two extremes. So over here, gradient 0, gradient 0. Okay, not all the other coordinates can be sort of transformed to new coordinates. In fact, for these, I have no clue what the gradient is at those locations, okay, because this gradient is not provided and this gradient is not provided. Okay, so we have no information to transform those points. However, for the turning point at -1, 4, we do know that the gradient is equal to 0 at that location, and therefore the y coordinate will become 0 at that location. So here it becomes a prime, -1, 0. Okay, so we can sort of label it onto our diagram now. Okay, this will be the point where the graph will intersect the x-axis, and that's all we know. So this point is the point A prime. Okay, now let us join the dots, or rather the key features that we have established. So over here, we know that we have a horizontal asymptote at y equals to 0. Okay, so maybe I'll label it in here as well. Okay, and then you ask yourself, at the current initial graph, is the gradient currently positive or negative? Okay, so if you look at this graph over here, we draw a tangent. It seems like it's slightly tilted down, and in fact it's getting more and more negative till this point where it's nearly negative infinity. So we know that the gradient is going to start off negative, so it's under the asymptote, and it will go towards the asymptote x equals to -2 here. So I drew a dot right beside the two endpoints, beside the asymptotes, and I know that I need to connect these two. So now connect the graph. Okay, so that's our first part done. Now after the asymptote, look over here, consider the gradient at these points. So notice it's coming downwards, so the gradient is negative. And what happens is that the gradient is starting to get more gentle till the turning point where it's 0. So we expect our graph to start off with a very negative value, negative gradient, and it's slowly getting larger till it hits 0. Okay, so let's just draw this out, rising till it hits 0. Okay, now this is the tricky part. How do we draw for the rest of this graph here? Now after the turning point, we have no information about the gradients in between. However, we know that eventually the gradient is going to be somewhat 0, right? Very close to 0, and currently over here the gradient is 0. So currently we are at here, and we know that the graph must end off right beside the x-axis. This is the horizontal asymptote. So the question is, how do I connect this point here to this point there? Right, do I just draw a straight line here? But that would mean that the gradient is 0 everywhere here. Not possible. Then you think about it. Oh, my gradient is actually rising. From 0 is getting positive, but yet is going to become flatter, 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 and become eventually close to 0. What does this imply? We're going to get some positive gradient values, but eventually, somewhere along the way, it must turn back and head towards 0. Okay, exactly where does this occur? You can somewhat see it from the original graph. There is somewhere in the middle here where the gradient starts to fall. So this is where the concavity changes. Now we don't know exactly where that happens, but we do know that maybe it's around somewhere in the middle here. Okay, so you don't have to worry about where exactly it turns. Right, the graph may not be as obvious, but we can see that probably around here, right, or here. It's hard to tell, but somewhere along the line we're going to turn back. So how does the graph look like? We're going to rise, and then we're going to fall again. Okay, now just check your graph that is just falling. Alright, so if it's not nice, just erase and draw it again. Okay, and this is all we are able to draw. Okay, so there's nothing to label over here because we don't know exactly where the concavity changes. Okay, so there's no need to label anything here. So the important points to label is the horizontal asymptote, the vertical asymptote, and the transform point over here. Oops, I made a typo. It should be -1, not -2. Okay, -1, 0. Alright, apologies for that. So this is your derivative graph. Maybe maybe let me just label this. Okay. Whereas this is your reciprocal graph. So the main procedure is to find the new key features. I would recommend labeling the asymptotes first and then put down the key features and see how you can connect them up. Okay, to make this slightly better, I'll just make sure it is tending towards the asymptote. Okay, so that is our parts 1 and 2. Now let's look at the last part, part B, where we are told to state the sequence of transformations that will transform this ellipse into the unit circle over here. So here we have the idea of replacement. Okay, what are we going to replace the x and y's by such that it will become our final product? Okay, so the idea of replacement is removing the entire y and putting in something else. It may be an addition or multiplication that will make some kind of effect to the expression. Okay, so just by looking at this expression starts and end, okay, we can see that the x's are the same. The right hand side one is the same, so there's no further manipulation that needs to be done. And now the only thing is about our y. Okay, so the transformation is all going to involve y. And we ask ourselves, how can we pull out the y, put in something such that you end up this at the end. So the first instinct is to get rid of the y minus 2, because eventually it's just a y squared. So the question is, what do I replace y with such that after some cancellation, manipulation, it would just be a y squared? So I hope you can see that we are going to replace y by y plus 2. Okay, such that when we simplify it, we're going to get x squared plus y over 2 squared equals to 1. Okay, so this is the simplification that will cancel off with this minus 2. Okay, so over here we are just replacing y by y minus 2. Oh, sorry, y plus 2. And in the second step, we are going to just tackle the y over 2 part. So what can I replace y with such that after cancellation is just a y squared? So I hope you can see that we are going to replace y by 2y. Okay, replace y by 2y. And in doing so, we can do some cancellation of the 2 and it will end up with just a y squared. Alright, so here what we are doing is replacing y by 2y. Okay, so with these two transformations or these two replacements, we can link them to the transformation involved. Okay, so this one, the order of the transformation is important. Step 1, it will be a replacement of y by y plus 2. So this is a translation. Alright, and we replace by y plus 2, so it's 2 units. Alright, in the which direction? Idea of opposites or different idea plus here. So here is a negative y direction. Okay, never say negative 2 units because units are all positive. So 2 units in the negative y direction. Okay, idea of opposites. If here is plus, here will be minus. Okay, step 2, replace y by 2y. So whatever we replace it is what we call the scale factor. So here, scale, parallel, please write in full, to y-axis, whatever variable that you replace is the axis that is parallel to, by scale factor 1 over k. So if you replace it by 2, we are having a scale factor of 1 over 2. Okay, so again, idea of opposites, if you replace with ky, the scale factor is 1 over k. Alright, so this is one of the approach, okay, method 1. Now, if you consider scaling first, then translate, alright, you have to check what is the translation, how many units, okay, because If you do the replacement, it may be different, right? If you replace by the same number of units, translate, it may not give you what you need. Okay, so very quickly running through, if we want to scale first, meaning if we replace y by 2y first, like this, okay, what we realize is after simplification, what we have is 2y divided by 2 is y, minus 2 divided by 2 is 1. You get this. Now, is that very hard at the next step? We are no longer translating by 2 units already. Now we are translating by just 1 unit. So if I replace y by y plus 1, then this is going to cancel off to become y squared. Okay, so if we go through this route, our first step will be scale parallel to y-axis. Similarly, by scale factor half. Okay, the scale factor will always be the same if you change the order, but the number of units where you translate will be different. So here, step 2, we translate, or we can say translation of 1 unit in the negative y direction. Okay, so this is the other method if you choose to scale first, then translate. Okay, but overarching principle, see what is the replacement to be done to get you to where you need to go, and then link it to the description of the transformation. Okay, that's it for this question.